Hello?
Guys, it's zoomed in.
Hello, how are you?
I'm good.
Good. So looks like Akshat is here and Vidhi's here and Morgan's here. Welcome. So this week we had a DevoWorm meeting and we talked about a lot of GSOC things. Remember that the GSOC deadline is coming up on the 31st. So the 31st is, I believe, next week. And so we're going to be pushing that deadline this week. So if everyone is working on their proposals, please make sure to send those into the GSOC portal. Make sure that you have, everything ready to go. And then, we'll make our selections, and I think they'll be announced sometime before the beginning of May. I'm not really sure what the timeline is this year for that. So our DevoWorm meeting this week, we had it was an hour and 40 minutes, so we had a lot of people presenting for GSOC. So we had Susan and Shreyas and Morgan to begin the meeting, and it looks like we talked about this figure here. This was from a talk that Susan gave. She does a lot of things on tensegrity structures and other things, and she's interested in tissue modeling, specifically different types of computational methods you would use for tissue modeling and for building simulations of biological cells and populations of biological cells. So, there are these different types of discrete models, there are continuous models, there are mixes of discrete and continuous models, there are heuristic models, physical models, and then design aids, which include finite element analysis and evolutionary algorithms. So that was just something I wanted to talk about. And then Susan had some things to say about that. And then Shreyas gave his presentation on his work that he's proposing in terms of interpolating the connectome. So he's thinking about the C. elegans connectome, which is a fairly small connectome and is well characterized. And he has that data set and he's interested in integrating the lineage. So he's looking at these graph neural networks that are time dependent. And so, he's looking at that. And one of the ways he wants to do that is to look at how the connectome is shaped in development, looking at the different time points, and then using methods to both project that into a higher dimensional space and to plot the network over time, and then to also look at the dynamical systems type of behavior that you see in this connectome. So a lot of interesting stuff here. He's talking about talks about why lineage matters for neurodevelopmental modeling. And so what he's doing is he's taking the data, he's projecting it into this hyperbolic space, which is a special kind of mathematical space that's different from Euclidean space. It allows for curvatures to be represented. And then using the lineage tree information to build these time-dependent structures. So he goes through his math and his... so he's using hypergraphs to encode these things. He's talking about collective motion, so he actually developed this method that's very similar to a Lagrangian coherent structure, in that you have these the cells are represented on this hyperbolic space, and it kind of looks like particles floating in a pool of water or something, or on the surface of a sphere. So it's kind of interesting. We talked about, I kind of drew that out on my board, and then we talked about it. And then he has some graphs here, so he's reporting some data for developmental stage, talking about lineage direction as a collective force. So this is where he gets into his ordinary differential equations that he's using on a hypergraph. And then, talking about a little bit about synaptogenesis in the connectome, in the developmental connectome. So this is all that there. And then, so that was Shreyas' presentation. We had some discussion after that, and then I ended up talking about Morgan's work. So Morgan last week in this meeting presented on his work um, for doing neurosimulation, and he built a stack in Claude to do that. And one of the repos that he has is this organoid benchmark, of course. So naturally, this is something we talked about in DevaWorm. This is the organoid benchmark. We just went through what's here and sort of the pipeline and talking about that a little bit. And he's adding things in from the different meetings. So people who are applying to GSOC, he's kind of taking that and putting it into the model. It's really interesting work, and he's got some nice data sets to mine for this activity. So that was Morgan, and then Susan presented her work on. Actually, I did talk about someone else's repo here, Hardik Singh, who did neural connectome growth simulation. So we talked a little bit about that. And then Susan gave her talk on modeling simple epithelium tissue using tensegrity structure. So she's interested in these super stable structures called tensegrity structures and applying it to groups of biological cells that form tissues or form other types of structures. And so this is kind of going through some of the work that she's doing. A lot of mechanical engineering, a lot of physics. This is the stress strain curve. So you have this response curve of the tissue. So when the tissue is under stress and strain, or it's under sort of perturbation, you have this relationship between stress and strain that has this sort of nonlinear curve. And so, that's what we're interested in. And with respect to tensegrities, the stress strain curve is more robust than it otherwise would be. We have these trijunctions, which are important, how the cells are organized in terms of how they meet together. So cells don't exist kind of in a vacuum, or they don't exist sort of independently. They're in this matrix, in contact with other cells, and then anchor to a substrate. And so this is kind of describing those anchor points and how they kind of form this metageometry for the tissue. And the tensegrities, we think, would be in those structures. So she's going through some of the computational modeling. She's modeling this, what they call a T3 tensegrity, and just kind of the simulations there, the boundary conditions, some sample graphs and tension and compression, so some displacement versus force graphs, and then some validation on long tissue data, and this hexagon 3-cell model, which is where 3 cells come together, and just different types of toy models like that. Then we had our GSOC students or GSOC aspirants give talks. So we had this talk by Utkarsh Tyagi. He was doing some 3-dimensional modeling and building a biophysical model. Really interesting stuff that he was presenting. So he had a bunch of things related to biophysics that he was modeling here. And he was using this package Cindy as well as GNNs to do some of this. Then we also had, I think Barshan, or Ashu actually, who did this work on looking at temporal developmental graphs, building a simulation engine for embryogenesis, building it into a developmental graph neural network, looking at the emergent connectome, and then hypergraph neural networks. And so this is kind of going through this, building this in Network X, in PyTorch geometric, and those sorts of things. And then this is some of her visualizations, which are interesting. This is the connectome graph here. This is a temporal graph of the connectome. And, this is plotting it out in 3 dimensions so you can explore it and look at the structure. And then we, of course, have statistics that we use to summarize these networks as well. And so this is, she brought up this C302 paper that OpenWorm published several years ago. And here, this is the C302 platform, which is well established in OpenWorm. And it basically is this relationship between like a connectome that you might get. You have neuroinformatic data that where the cells are labeled, and then you plug it into the simulation platform. You use Neuron and you use other Python scripts to analyze it. So fitting that into C302 might be really interesting as well. Okay, so that's all we have on the DevoWorm meeting, and so yeah, that's good. And we've been working on GSOC applications. Now, when we get to about the 1st of May, we're going to start up our open source meetings for the year. So our open source meetings are usually an hour long, maybe an hour and 10 minutes long, and it is and it is on Fridays right around noon Eastern time in North America. So I don't know what that is in India, but we'll kind of figure out who wants to attend. Everyone's free to attend. If you're accepted to GSOC, of course you have to attend. But if you worked with our group and you weren't accepted to GSOC, you can still attend the open source meetings. And we do actually go well beyond GSOC. So the idea of the open source meetings is to present GSOC projects, but also to talk about topics in open source. And then if we're doing open source projects independently of GSOC, we can talk about those and present on those and everything else. I usually do a topic in open source every meeting, so we maybe spend 15 minutes on that. And so it's a nice professional development opportunity. So I'll be in touch more about that as we get closer to the time. But usually between May and October, May and September, we usually run these open source meetings in the lab, and I think it's very useful to people. We also have them on our YouTube channel from past years, so you can check out what we were talking about last year, for example, and get a sense of what we're doing. Okay, so I guess we want to present today. I know we have a number of people wanting to present their projects. So who wants to go first?
I'm audible, right? Hi, I'm Vidhi. For those of you who don't know, I have contributed to GSOC, like I've contributed to Oral as a part of the Google Summer of Code already. And I was a part of Oral, like I've been a part of Oral since 1 year now. And I did the Sustain Hub project, the open source community sustainability project last year, like the GSOC 2026 project. I'm presenting today uh, as the part of the extension of this project, like the part of the project which I would be doing in 2026. So before I actually talk about what my proposal for 2026 is, since it's a continuation of the previous project, I would like to talk a bit about that project as well, because some people over here don't really know what that project was. But yeah, like Bradley, Morgan, Sarah, no, because you all are my mentors. So I named the open source community sustainability project as Sustain Hub, and it was mentored by Bradley, Jesse, Sarah, Mehul, and Morgan. So thanks a lot to my mentors. And yeah, just to let you all know, I am Vidhi. I'm a third year BTech student pursuing computer engineering at VJTI. And yeah, so talking about the project, so basically, we know that open source communities, for example, GitHub is a big example of open source communities, and we have GitLab and other examples as well. So we see that there's some uneven workload distribution, there's some contributor burnout, there are dropouts, there are knowledge related queries, and whatnot. And then it's hard to maintain the long term sustainability. So the main problem statement is that how do we keep an open source community stable and efficient? So for that, we have this project, and I propose Sustain Hub for that. So the overview of the project is that it is an agent-based simulation of the open source community, and it models the real contributors and tasks. So I have used reinforcement learning for task allocation and decision making, and I used, like, the goal was to have balanced workload and high engagement. Right. So continuing with it, I categorized the whole thing into like four agents, and the four agents were maintainers for assigning the tasks, contributors for fixing the bugs, innovators for building features, and knowledge curators for documentation. So there can be more, but I briefly categorized the contributors into these three categories, four rather, because previously when this project had been done, there were only two types of agents, like the maintainer and the contributor, but I classified the contributor into three different classifications as well, and the maintainer remains the same. So since I use reinforcement learning, and we know that reinforcement learning involves math, and majorly reinforcement learning means that there's an agent which acts in an environment, and based on how it has performed an action in an environment, it gets a reward, and the reward can be positive or negative, and based on the reward, it takes the further actions. So, like as I mentioned earlier, like contributors supposed to do the bugs, innovators do the features, knowledge creators do the docs. So what I did was that so that the contributor does bugs, it gets a higher reward for that, like it gets +3 for that, -1 for failure, and 0 if it skips the tasks. And similarly for innovator and knowledge curator, and for the other ones, if the contributor is doing a feature task, it gets a +1 and -1 for failure. So this was like the basic math that I used in the simulation. And yeah, talking more about the reinforcement learning part. So there were basically two main RL algorithms that I used: multi-armed bandits, which was more on the math side, which was exploration and exploitation, and SARSA, which is state action, reward, state action, where the agent learns behavior over time. So this is the picture of how multi-armed bandits work. So this is the maintainer, and the arms are nothing but the tasks, and A, B, C, D, E, F are the contributors. So this is just to show how it works. But this was done mathematically in the project. So moving on, this was the equation. I don't want to get into, like, I don't want to get much into a technical part of the project, but yeah, talking about what I had used, this was the Thompson sampling in multi-armed bandits, where theta was dependent on the successes and failures. So every time a contributor did a task, we used to either calculate its success or failure. Success means it has done the task, and failure if it hasn't done the task. So this is the basic math behind it. And yeah, I don't want to get very technical, but then when I talk about the future scope of this project, I have a comparison. That's why a math brief. Then we had the SARSA working to state action, reward, state action. So this is the basic equation of SARSA, where Q is the Q value of like the particular state and action, which gets updated based on the current state and the action Q value plus the learning rate plus reward. And yeah, gamma is the discount factor with the next state minus the Q value of the current state. So this is the equation that we use for SARSA in general. And this is the equation that I used for calculating the Q values for each of the contributors in my GSOC 2025 project. And these were the outputs. So step one, basically I was running it for a lot of steps, and after every step I was showing these outputs of the contributors and how they have performed. So the maintainer would assign tasks using multi-armed bandits. So these three steps talk about that, and the next three talk about the uh, results of the assigned tasks, that whether they were performed or whether they were not. And then using the success rate, like the success rate formula that we have, we calculated the success rate for each of the tasks. So how many are assigned and how many are done, and then based on that the success rate. So like that for every step I used to show. So yeah. And then the Q values were stored in the JSON tables like this. So there were three types of tasks, like bug, feature, and docs. And based on whether it has done the task or skipped the task, I use the Q values used to be updated after each and every step and each and every simulation that I had. Like every single time you had to run the simulation. So like we can see over here, do task for docs is negative. That means it has not done the task. And for bug, it is very high, it is 0.79. That's why mostly it has been classified, this contributor has been classified as a contributor, not a knowledge curator. And yeah, like this was a lot about what I did last year, so my mentors know, but about the other people, right? So this was again one of the graphs that I had used to show how the outputs are. Like after a lot of steps of running it, we can see that contributor one has done the bug task around 89.7 times, and then similarly for the three tasks and all the 10 agents. Over here this image shows 10, but then when I had done the project, I had like the final uh, simulation which was created could actually have more agents involved. But anyways, right, so the project also involved some metrics. The metrics were harmony index for calculating the workload balance, resilience quotient for handling the dropouts, and reassignment overhead for calculating the efficiency. So the major reason for these metrics was for that, so that we can check how well the RL simulation is, and the metrics would give us some output, and with the output we would figure out whether the project is doing well or not, and if it's not doing well, then how can we improve it and how much improvement does it need. So the metrics were just to show the outputs and how much we can improve. So a bit more about the metrics. The harmony index was around zero point 0.8. The resonance quotient was between 1 to 5. Harmony index, the range was 0 to 1, but a good harmony index was around zero point 0.8 and above. Resonance quotient had a range of 1 to 5, and it improved the task distribution, stability, and I had built a GUI, which was a graphical user interface, and a visualization dashboard. So this is how the metrics would look, and this is just a graph of the metrics on the visualization dashboard, which is it shows the range, like how I said, around zero point 0.8. It's a good range for harmony index. The reassignment overhead has a big range, and and the resonance quotient has a bigger range, but reassignment overhead is constantly one. That means each and every task is being reassigned if it is not done. So why I chose what I chose in 2025, the different agents, so that we can have a better real world simulation, and we can differentiate between the different types of contributors based on their skills, goals, and behaviors, and to enable richer interaction dynamics. Why the multi-armed bandits? Because it used to balance between exploration and exploitation, and it was just simple math, so it would help us achieve what we wanted. Why SARSA? Because the name itself suggests state action, reward state action, so that we can learn from the ongoing interactions and adapt the strategies to continue over time. And the combination of multi-armed bandits plus SARSA, because multi-armed bandits is quick, adaptive, and SARSA refines the behavior through experience-based learning. And the metrics just help us understand better, as I spoke about it before. So this is just about a few results of my project from last year. And this was the simulation where the blue circles are nothing but the contributors, and the yellow squares are the tasks. So if the contributor touches the task, that means it's done. It just was just a simulation that I wanted to show, apart from the math and the outputs which were there in the GUI. And yeah, so I documented everything into a paper which is available on GitHub right now in the same repository as where I did the project. So if any of you all want to go through it, you all can go through this paper and get a better understanding of the project with the details and the math which is used. And I used to update the README. So I updated the README to talk about how we can run the project and basically what the project was, along with a blog page. So the blog page had a weekly explanation of what I did in each week. So you all can go through that as well. So now talking about my vision for 2026. So since it is a continuation of the project, I would like to make the project smarter, more realistic, and like a resource level system. So it is a simulation, but from a simulation, I want to go to an intelligent adaptive system in a simulation itself, because we can't achieve a lot of real world right now because it requires a lot of hardware, but I would want to improve this simulation. So the key improvements that I propose this year are contextual task allocation, SARSA Lambda for long-term learning, new sustainability metrics, and some comparative analysis of the models. So the first improvement is contextual bandits. So instead of just using multi-armed bandits, we can use contextual Thompson sampling. So it uses workload, skill match, burnout, and the benefit is that there is better task agent matching. So basically, this is the formula over here, that theta is the probability of some theta with some context, and what AT is over here, that it's the maximum of this value. So this is the older one that I had used in 2025, where the theta depends only on theta A, which is the history, and the theta new depends, like the theta for like contextual the contextual bandits will actually have theta as well as xt, and xt is nothing but some context which is given to the thing. So it is not only on the basis of history, but also some context. So along with history, we can add some context about which contributor can do which task well. So the first few steps will obviously use just map, but then after that, we can have this as a middle step. Will directly start with this so that there's some context involved, and we can get a better understanding. So task allocation becomes state aware instead of history only. And these two are the papers which I had referred to which motivated me to use contextual Thompson sampling. Then the second improvement is SARSA Lambda. So it adds memory, which is the eligibility traces, and it learns long-term effects and captures burnout accumulation with delayed rewards. So this is the SARSA 2025 working, which I spoke about a while ago, where this is the equation, the standard equation for SARSA. But if we see SARSA Lambda, this is the equation where we have an extra e term involved. So this delta is the same as this thing that is in the squared brackets after the learning rate alpha. So we have alpha, delta, and this is the E, which is the eligibility trace, which tracks how recently and frequently a state action pair was visited. So the state action pair visited in our case is nothing but a contributor and the task which has done. So over here, like, we kept on updating this, but then rather than updating this, we can make the use of the history that we get from this. For example, contributor one does bugs more, so it can do more of the bugs by using this thing. And for that we have this SARSA lambda, which will help us. So we have the eligibility trace for that, which will help us perform better. And yeah, this is just a bit more theoretical, that captures more long term effects and updates multiple past actions, not only the latest one, and it's faster and more efficient. So that is about Salsa Lambda. Now, about the metrics, because my previous project also had some metrics like the harmony index, resilience quotient, and the reassignment overhead. There are three more, which is the burnout risk score, skill utilization efficiency, and common health score. So these are just some metrics which would probably help, like which will help me in the project more and understand how well the new Salsa Lambda and the contextual map is in the project. And we shift from performance to sustainability evaluation and the experiments and validation. But before I talk about this, why are these improvements there, like especially improvement 1 and 2? Because last year when I was doing the project, if there was something, a result that I was getting after running the simulation for around 7-8 times, we can use these two newer techniques, Salsa Lambda and the contextual map, and we can get the same results in the the running of the first few simulations itself. So if we get something in the seventh simulation, we can get the result in the third or fourth simulation itself. That's the aim. And yeah, so talking about the experiments and the validation. So the current model is multi-arms bandits with plus SARSA. But once I improve the multi-arms bandit, we will have the contextual Thompson sampling with SARSA. Then we can compare map with the new SARSA, and then we can compare both the new tech. Like we can add the new techniques, contextual this thing and SARSA, and we can compare everything. So we will know which of the four models is better. Is the previous project better, or are the two new improvements better, or a combination of these? And then we can obviously evaluate the conversions, burnout, and efficiency.
Well, thank you. That was great, Vidhi.
Okay.
Did we have any questions or comments? So yeah, that looks great. So you're just proposing to add things on, and those things are going to improve the performance, or kind of add some depth
Yeah.
to the performance.
Yeah, sorry. I just included more of the technical part of it, like the new RL algos that I would be doing probably. And I didn't like, but obviously it goes along that I would continue with the blog post every week and improve the simulation that I had last year. So yeah, about that.
Yeah. So could you pull up your slides again? I wanted to see that last slide where you were talking about the things you want to
Okay.
evaluate this year. Yeah, that one.
This
So you're evaluating burnout, convergence, and efficiency. So what is
yeah.
convergence?
Convergence tells us like earlier, like if you remember last year when I did the project, the earlier the agents were unclassified. So they used to remain unclassified until and unless, like, for the number of times I used to keep running the simulation again and again. So there used to be some edge cases where the agents were still remaining unclassified. So they can get classified sooner, and like the correct classification, whether it's a knowledge curator or an innovator or something. So we can have the convergence of the correct, like the correct labeling or the correct classification, as well as them being assigned the correct tasks earlier as possible. So that's why convergence.
Okay. Yeah, and then burnout, we know
Yeah.
what that is. Efficiency, we know what that
Yeah.
is. I mean, burnout, you
Yeah.
have like equations in mind for this, or you have ways that you
Right.
have in mind to measure them, right?
Right. Right.
Okay. Morgan, did you
Okay.
have a question?
Well, excuse me. Sorry, I am driving, but I am hands free. Um, the but just a kind of philosophical question or a kind of architecture
Okay.
question. So this is a centralized system, yeah. Like
Okay.
there's and what you're comparing are kind of different centralized systems in terms of their metrics, um, in terms of the agents. How much autonomy do the agents have in their tasks? That they're totally assigned, right?
Yeah, they're totally assigned, and then they have the main autonomy that they have is in the beginning, where all of them are unclassified, so they don't know what they're going to be assigned, and based on their actions, they will be given some classification. And the next
Okay.
autonomy that they get is whether they will do the task or not. So they can skip task, or if they do it, and if there's a success or failure. So that's the part of autonomy in the agents.
Gotcha.
Because after they have been classified, there's a very less chance that they would actually want to do some other kind of task, because there's a particular task that they are good at. That's why they have been classified as a particular agent. So they have autonomy throughout the project.
Okay. Yeah. No, just making sure I understood, and you know, like it's been very interesting to read your paper and to
Right.
learn about the methods you're applying. So yeah, thank you.
Yeah.
Welcome. Thanks.
Yeah, Morgan, thank you.
Hi.
Hi.
Hi. I'm traveling, so the network might be a bit dodgy. So I was able to go follow your presentation somewhat. I go through it more in detail later. But one of the questions I had was, have you given any thought to some kind of collaboration as a feature for this course between agents?
Not yet. I was completely relying on a particular agent doing one task, but I think we can have this as a part of it, that if a task is big, then we can have some metrics for the size of the task, and depending on the size of the task, we can involve a few number of agents. I'll have to look into it, and if it has been implemented before, and since it's RL, how will the math work over there? So I'll look into that, and I'll get back to you on it.
Yeah, sure.
Okay.
All right. Yeah, thank you.
Okay.
Yeah, any other questions? So yeah, I enjoyed this project last year, and we're doing, so this is for people who don't know, this is sort of our reinforcement learning part of the project. So we have the large language models part of the project, and people have been putting in pull requests for that. And then we have the reinforcement learning, and there's a lot to do in the reinforcement learning area as well. Like, this is like pulling all the threads together. But we do have other reinforcement learning code, other types of things that we're doing there. We also want to kind of make links to active inference, and I'm particularly interested in this link to active inference because it not only is it sort of we've done this before, but I see people more and more making ties between reinforcement learning and active inference, and it's really, I think, for agents, it's at least something to consider using in terms of the model. I don't suggest that Vidhi use it in this case. I think she's got a good set of things that she wants to explore in this proposal, but just to throw that out there. When we're doing a lot of this work. Now, that being said, the large language models and the reinforcement learning kind of remain separate up to this point. So I don't know how much sense it makes to kind of integrate those in different ways, but definitely I think that's something that is maybe a next step. Although I think for now we would work on separate tracks, at least for this summer. So that's that. But thank you, Vidhi, for presenting on that. Okay, we have other people want to present.
So, hi everyone. My name is Riya, and I'm a recent graduate in computer science engineering, and I have been contributing to this environment in this repository, and this is my proposal, presentation regarding my proposal.
Okay.
So, I propose adding a conversation space to LLM OSC. So these were some of the issues which were addressed, and according to these keeping in mind, I have created my architecture on how I want to proceed. This was my adding a conversation space to LLM OSCs. That's my proposal. So these were the issues that I kept in mind and the comments on this for creating my proposal. The real world data ingestion and research backed RAG and real world community sustainability and engagement metrics and front end integration. So my proposed solution is divided into three layers. First layer is world grounding, where I would be ingesting real world archives from Slack, IRC, and Discord. The second layer is event sourcing. This is the part where the conversation space is there, along with engagement metrics. And the third part is the agentic RAG. So the first, going to the first layer. So this is divided into four parts. So the first part, I'll be ingesting and parsing data, Slack, IRC, and Discord. So to get us to make it and then I would move to creating it into a common message schema, and then I would be moving on to chunking because not every message would make like the context won't be that much. So chunking them based on threading and time would make the semantic retrieval during the simulation. And then I would be converting it into vectors using the embedding model Nomic. So the key architectures of this layer are like I have done the research regarding it, and I've evaluated and compared with other like methods present out there, and all the details I've like linked in my proposal document. So these are the things that I'm proposing right now. So the database, I'm going with Chroma database because the latency is 20 milliseconds, which is negligible compared to Olama's 2 to 5 seconds inference. And the embedding model that I have proposing here is Nomic embed model because it's the only open source model to outperform text embedding ADA on MTEB retrieval and runs via Olama. And the thread chunking is the same way that I've like discussed just now. So going on to the layer 2 is the event sourcing. Here is the where the conversation space is there. This is also divided into three parts. The first part is ingestion. So this is the part where the layer 1 orchestrates or it starts, the pipeline starts. And the second, the retrieval is the one which is being used by the RAG. Here the queries from the Chroma DB with role aware and simulation aware filters, and the metrics are the open source health community metrics and sustainability score. And going on to the layer 3, that's agentic RAG. So why am I proposing RAG here is because right now the knowledge that the agents have is parametric knowledge. They don't have real like open source archives and open source history, which makes the response generic. And so it bridges the gap between the layer 1, which is the normalized or schematic data, and the agentic behavior. But at the same time, I'm not going with standard RAG because standard RAG will lead to single agent and single pass, which will lead to each contributor retrieving independently and not aware of the prior agents discussion that have taken place, and cannot differentiate retrieval by contributor role versus maintainer role. So I propose modular multi-agent RAG. So in my proposal, I have researched regarding it, and the evaluation and if everything is linked to that. So just a brief idea that why modular. So here it's divided into the RAG is divided into four discrete models. Each of the discrete model is independent and easily replaceable without touching the agent code. And it's multi-agent because they have a shared context pool plus discussion coverage signal is used, which means each agent's retrieval is shaped by prior agent's discussion. And role aware because planner differentiate contributor queries from maintainer queries. So the layer three's overview. So there are three phases involved. The first phase is issue level shared retrieval, which runs only once in the starting. The planner creates a query and the retrieval happens, and the filter shared context pool is stored in conversation space available to all contributors. So this data which has been retrieved is available to all the contributors. Phase two is contributor personalized. So here, at every contributor's turn, planner will give role-based plus the discussion-based query, which will be personalized to particular contributor. The retrieval will take place, and the filter part will penalize already covered angles, so that every time there's a new angle we are discovering to the problem. And the synthesis will order it or construct it properly before giving the query to the ulama. And the phase three is the maintainer selection. So after discussion, if the algorithm is authoritarian, maintainer retrieves real contributor patterns for this discovery tier to calibrate contributor agent ratings. If the algorithm is decentralized, contributors retrieve real community approaches to similar issues to ground their self-bid. So, as I said, the RAG is divided into four configurable modules. The first module being planner. So that decides the query type, the metadata filtering, and the recency window, like how recent should be the data which is being retrieved for the agent role. And the retrieval is more of a semantic retrieval of the metadata. And the filter is relevance, where we have the score, we have a relevance score, so which is backed up by a research paper, which penalizes angles that have already been discussed. And and the synthesis is basically construction of all the queries and blocks, so and timestamps, so before giving it to the ulama. And this is the important part, multi-agent coordination. So there are 3 points in where the modules are shared across agents and not running independently. First is shared context pool. So issue level retrieval runs once. So all the contributors draw from the same base context pool rather than each time running redundant queries. Discussion coverage signal. Growing discussion history is fed back to the filter module. Chunks covering angles already discussed are penalized. The discussion shapes its own retrieval. And the third part is collective track record, which is used by the synthesis module, runs once per contributor being evaluated. In authoritarian mode, difficulty match contributor pattern, query to calibrate maintainer ratings, and in decentralized, similar issues query to ground each contributor's self-bid. So this is the timeline, and this is the front-end integration that I have been proposing, which includes matrix dashboard, Slack-like discussion view, sustainability score, and conversation space panel.
Yeah, hello. Hi, am I audible?
Yeah.
Yeah, so a few questions. Firstly, I saw that whenever you mention about the agents talking, you were only talking about it from an issue perspective. Like, you were like currently how it happens in the authoritarian and decentralized models.
Yeah.
So the conversation that happens currently, you're trying to replace it with RAP, right? Yeah, but I mean, the whole idea of conversation space was to simulate all the conversation that would happen in an open source community. And that was the reason we are pulling in archives from Slack and Discord. On Slack and Discord, people don't usually talk that much about the GitHub issues. That conversation is done on the GitHub PR comment section, and that will stay. Like, that's already implemented and that will stay, right? But what we're trying to enhance is the conversation that would happen otherwise. The whole community that would talk about everything, about how they want to progress, about new contributors coming in, and about everything that happens in an open source community. So I feel like you should focus on that, not try to. It's okay if you want to enhance the way the authoritarian or the decentralized model also works. So that would be a different thing, but that would not be the solution to the issue of conversation space. the issue of conversation space relates not at all to GitHub.
Okay, but the conversation will still happen, but will be assisted with RAG.
I'm saying, yeah, I understand. That's what you're proposing, right?
Yeah.
I'm saying that the issues, I mean, the comments that are left on issues, even if there is say 50 to 100 issues in some repo, and each issue will have maybe like 5 to 10 comments, that still does not justify a whole RAG database. What justifies a RAG database is a conversation where everything from hi, a new person has joined, to everything that anybody can talk about. Like you take our community, for example, you go through all the channels on our Slack, and there's so much context there. It's people sharing papers, people sharing what they did this week. All of that, some of that takes growth into it. It's people talking about GSOC, for example, or any other such programs that may happen regularly in an open source community. There's also, when you start studying about open source community, there's a lot of talk about how people are incentivized to contribute because there is no incentive or there's no monetary incentive. So there is this talk about how to get new contributors in, how to keep the contributors who are there, how to keep them integrated and attached with the community, how to build community. And that is where the people talking to each other face comes in, right? It's not the PRs, the comments on PRs. Like that is a part of it, but that's not the whole thing. So you should focus on that because on Slack people don't talk about PRs, right? Usually, or Discord or any other IRC. So that would be the first thing. Secondly, you said you have looked into taking in Discord and Slack architects. So how have you looked into them? What software? What licensing? Have you thought about all of that?
Yes, I have. The archives are available, but I'll have to look into it more. But yeah,
So by archives, do you mean some specific data sets or any Slack channel, any Slack workspace, any Discord channel?
Yeah, I mean, I have to look into it more, but there are modules for parsing, so I was thinking of using them.
Yeah, parsing is one thing, but also how would you get the data? Because there's...
I will look into that.
Yeah, so yeah, that's one thing. And then also the front end integration part you skimmed through, I think, quite quickly. But one doubt I had was if you can just go back on that slide.
Okay, 1 second.
The front end integration. Basically, my doubt is that how would you, so all this, when you say that, query Olama is called and all these agents are talking to each other, are they talking in a multi-agent format or are they talking with like English, like spoken language? Do we have, when they're talking to each other, do we have enough conversation to relate to front end?
Yes, they are talking in spoken English language.
Okay, great. So I think one other thing you can look into is how they would talk, not just about the issues. Issues is a very small part. We already have methods for that, the authoritarian and decentralized model. All you can do is plug those existing modules into your conversation space. So maybe you could decide you could have a separate conversation space for chat, and you could have a separate conversation space. Like chat would be equivalent to whatever the organization uses, Slack, Discord, whatever, and you could have a separate conversation space for the GitHub related, code related, review related things, where who has to solve this issue, what is the maintainer's review on it, and everything.
So will the agents will be participating in chat and will be like
yes, both
different from simulation?
No, they will be the same agents. It will influence each other. The same way in an actual open source community. If people are talking more, you will find data on all of this and you need to research about it. But as far as I know, there would be some patterns, like people who are more active in the community would also contribute more, and maybe they would be the senior people maybe they don't have that many lines of code, but they're more active because they are reviewing more and they are talking more and they're sharing knowledge. There's knowledge transfer and all of that. So there'll be patterns, and that is what we can simulate, right? So there'll be metrics, and that is what we can simulate.
Okay.
And another thing is you should also look into metrics for all of this.
Okay.
And a small technical doubt, you said at the beginning that you are preferring ChromaDB as its inference is faster than Olama. So were you talking about Olama as a database?
No. Like Olama is in local. The Chroma database will be local and then running it.
Right, but I'm not understanding why did you compare it with Olama?
No, I compared with other databases like Pinecone and others.
Okay. I thought because in your slide, I'm pretty sure it said that Olama's inference is about some seconds and this is something else. So that line I was confused about.
So basically, it goes together. It's like it's Olamas is more, but as it is less, it will be able to collaborate, do it with together basically. That's what
okay, maybe you can just DM me about this. I'm still not.
Sure.
I still have some questions. Yeah. If anybody else has some questions, please go ahead.
Yeah. So the Olama, you're just running it on Olama. You're training it with the database. Okay. Yeah. This RAG idea is pretty interesting. I mean, we've been playing with them a little bit. Where you can customize it with specific data sets, and you can see, if you can kind of get really specific, prompts and things like that, and see if you can get really niche kinds of answers out of the large language model. So I mean, another thing, and I don't want to confuse this too much, but like Sarrah was talking about how our discussions sometimes are different in terms of the different media we're using. So if we're on GitHub, we're maybe having issues around specific issue or discussions around specific issues. If we're in Slack, we're having different types of discussions. It's just of quality. Sometimes, of course, they overlap. So this is going to be like totally dependent on the team style. Some teams will just kind of do everything in GitHub. They'll have long discussions there. Sometimes they'll have different types of discussions in Slack. And so and then of course you do have that difference in this like authoritarian versus decentralized. A lot of times that may show up in the discussions, but it may also be like there's this style of management that is, it might show up in the discussions, it might not. And it's hard to say, it's hard to make that distinction. So, I mean, some of this is going to be, harder to, because it varies so much by team so we can model it, and we have to be very explicit about what we're modeling. Yeah. So if we decide we're going to model maybe an authoritarian style of issuing, just creating issues, we might have one person who creates all the issues, and then like everyone has to sort of follow those to the letter, versus a team that just kind of creates their own issues, and there's a lot of discussion about the structure and form of the issue and all of that. So those are like both possible, but we don't want to muddy the waters too much. We want to just have like one methodology for doing this. And so that's kind of important to keep in mind, is like, we don't want to, when we do experiments, we want to keep as many things constant as possible, and then we can like kind of deal with the details later. So that's just, really kind of thinking about how you would kind of get started and structure things, and you have to make decisions sometimes about how you're defining a conversation, because sometimes conversations are this is not an easy problem. I know using large language models makes this look easy, where you can parse discussions and get simulate things, but really discussions are going to be very different based on power relations, right? Who's talking to who? It could be just kind of the style that a lot of people just kind of do things in GitHub. Some teams will be more formal and have like things in Slack, and they'll just stick to certain things in Slack and certain things in GitHub. And sometimes it's just they're using in person. So sometimes their modality is like in person meetings. So they don't talk about a lot of things there. They'll talk about some things in Slack, maybe some things in GitHub related to the issues, but most of it is like synchronous communication. So that's another problem is that if you took a data set, and we don't have good access to like different teams because they usually are private, but if we had a data set from like, if we had data from 10 different teams, that data would be very widely variable in terms of how the discussion would flow, right? Because every team has its own kind of style. So we have to kind of think about normalizing this and making sure that we don't kind of bite off more than we can chew on this. Yeah. Well, yeah. No, I think it's great work, and I like this idea of using a rag, and I think at this point, it's like kind of be just seeing if you can get it implemented, and say, this is how it could work. This is how we can, kind of tailor it to discussions because there are unique challenges there, and that sort of thing. All right. Thank you.
Yeah, thank you.
So we had Vidhi and Riya, and did we have anyone else who? Okay, Akshat wants to present.
So I wasn't able to make a dedicated PPT, so I'd like to present my proposal form, and I'd just like to start a bit on where my thinking started. So we are basically talking about adding a conversation space to enhance the simulation that some communities use Slack to talk. So the talking in Slack is obviously bound to change the GitHub PRs and issues, etc. So I've been thinking of reworking the motivation system we have in the project. So the current motivation here I'll show. The current motivation is a bit like this. If someone's PRs get accepted, then his or her motivation rises. If they get rejected, then it falls down. So this is a very good starting point, but I believe it will become more complex and it will need to be updated whenever we add the conversation space. So I have looked through some research papers on motivation, and in open source communities, motivation is the primary predictor of contributor productivity and retention. So motivation is basically the central thing for this project. And one more research quantified the prediction of individual motivators. And here it divides basically into two types of motivations. First is intrinsic motivation. We've also studied it as internal motivation and external motivation such as money or community. So this is the table from this paper, and as we can see, the internal motivators, enjoyment, ownership, learning, things which are limited to oneself internally, they are much more better at predicting the motivation, and these should be focused in an open source to help increase its sustainability. And external motivators are rated a bit below at prediction of a motivator. So now this one was a bit surprising to me as well. Payment doesn't cause as much motivation as enjoyment or ownership, most likely due to burnouts or some other things. So firstly, I would like to rework this motivation system, and I'll use these as weights to update a motivation whenever when an action takes place. Now, second is I want to talk about the agent actions. Now, actions of an agent right now, they are just submitting PRs and reviewing the code. So I'd like to expand the action set of one agent. So they can join a project, they can talk in conversation space, they can comment on a GitHub issue or a PR for a better structured discussion. They can submit the PR. Now this is currently implemented. I don't think this would need much more work. The core members can assign issues, reviewing code whenever available, opening a GitHub issue. Right now, everything starts at the beginning, and the contributors don't open the issue. It is basically opened by the system. So I'd like to implement the capability for an agent to open the issue as well. Leaving the project, I'll talk about the leaving and joining part later, and mentioning another contributor. Now I think this is very central part to emulating a real discussion. We use @signs to mention other contributors, such as someone has started talking, so we would mention them and continue the conversation that way. So these are the actions one agent can have. I'll refer to them as actions from now on. Now this is my favorite part. I think Vidhi also touched on this on her presentation. Roles in an OSS project. So I've gone through this paper by Chang and Guo, and they have analyzed more than 20,000 unique contributors in 29 GitHub projects. Now, I'd like to make this diagram a bit bigger. So, this is basically them clustering the overall contributors into two major groups. So there's basically two groups: supporting participants, which are the silent majority. They provide much less value to the project compared to the active participants, which are the minority, but they do most of the work. So I think in the current implementation of the project, uh, we can use analogy that supporting participants are the contributors and active participants are the maintainers. So this is the first thing. And now these are the major groups. These groups are divided into minor groups as well. Uh, yeah. So here are the minor groups, which are the active contributors can be divided into. Now these are based on the actions they take. So intense code contributors, coordinators, code developers, and all-rounders. These are the four major groups, and they all perform different actions. So here are the actions they perform. So all-rounders are the middle part. They perform everything at an around equal level respect to each other. Coordinators, they focus on issue reporting and knowledge sharing and issue coordination. Code developers focus on progress control the most, and they don't report issue as much. Now this is my favorite group, intense code contributors. They are the ones focused on code contribution. As you can see, the part actually goes out of the diagram. So they are very focused on the code contribution part. So we can model the maintainers based on these roles. We can assign them one role and then model it. For example, if we assign one maintainer agent to be code developer, then he would not report many issues, but he will focus on progress control and knowledge sharing. So this way we can actually test how the open source project will develop under one type of maintainer. And similarly, the contributors can also be assigned into 6 different roles. Now, I think only one group stands out here the most. Those are the rare contributors. These are the majority, and they provide the least value. As we can see, they have almost everywhere they have the lowest distance from the center. And we have some specialized supporting contributors. Some engage in issues, some engage in fixing those issues, and there are progress based also. So we can basically model these roles into our project, so we can test how better how which leadership is best for an open source to be sustainable, and what type of contributors supporters are best. Now, one more thing I'd like to say here is the changes in role. Now we know that one person who is a core developer will get burnt out and he may move to a smaller role, or there's someone who is highly motivated and highly skilled, so he can move into a upper role to be a maintainer of the project. So we can use this graph to model a Markov state type of diagram, that if someone is a rare contributor, that means he rarely contributes, then he is most likely to leave the project, that is being absent. Now, I'd like to point out the rare contributors. These are the these are the most, they like, if someone is absent, then he is most likely to become a rare contributor. And if someone is a rare contributor here, then he is most likely to be absent. So this shows that the current simulation basically keeps them in a box. So I'd like to model also this to be more dynamic. We would like to give one agent the freedom to leave or to join a project. So I have talked about this later. Now I am skimming this through a bit, but here's the diagram I have made. The current model is like this. We are essentially keeping them in a box. They can't leave or they can't join. So I'd like to propose an active classroom type of approach. We have the watchers who are looking at the project, but they are not contributing and they are outside the room. On the doorway, there are rare contributors, those who contribute the least. They have the tendency to leave and they have the tendency to join the more active roles. Supporters can become the all four roles can transmit to trans can convert to another role based on this diagram I have shown here. So any feedback on this approach?
Yes, you are. Oh yeah, okay. So this is
Yeah.
you're audible. Did you want to?
Yeah.
Are you
So
done
any
with your
feedback on?
presentation, or or do you
No,
want to?
I'm at a checkpoint. I'm like halfway through my
Okay,
presentation. I'd
yeah.
like to just get
just
the feedback
just
on
checking.
this.
Okay, yeah, go ahead.
Yeah. So I'd like to get any feedback on this new proposed architecture. Instead of keeping them in a box, we are keeping them in a classroom.
Yeah, I think that's great. So this is something that I think I'd like to say now, that like there is this opportunity to combine the large language model and the reinforcement learning part. So I like the idea of having the motivations. So one of the
Yes.
things we're building on is ultimately with reinforcement learning are motivations. So reinforcement learning is about policies, but to get those policies, people have to be motivated by something, internally and externally.
Yeah.
And then this idea that we want to have the box or the active classroom instead of this box is key, because we want to have like a
We
community
want
that
to have
changes its
different
structure.
personalities.
Yeah.
Yeah.
Yeah, I agree as well. Like, that's exactly the kind of way we want to move forward, like, make it more realistic. And also, another thing would be if the initial kind of contributors we have for this, right? Is to understand how we always keep an initial state of the repository and then we try to simulate from that point onwards. So, even I would like if the initial state was also modeled in this way. So you could go through maybe the existing GitHub, the existing conversation, and again, this would be a very good use case for RAG. and you could understand what are the type of contributors now, what roles do they already have, how many active contributors are there, how many supporting contributors are there, and then every simulation could show that, if your open source community is at this stage, this is where it could lead to.
Yes.
And
So,
also having different things that could influence this. Sorry.
So about the initial state, I had this idea for this graph that under we are able to program what type of contributors currently they are acting as. So we can test like what happens under an all-rounder leadership, what happens under an intense code contributor. So I was thinking that initial state would be choosable by us users through the front end.
Yeah, that would be a very good starting point. If we could do it somehow to, automatically get it from the current state of the community using methods like parsing, and that would be like an add-on feature. So, of course, the first step and the first testing way would be, done by the user, so the user can simulate. So that's fine.
Yes.
Yeah.
So
It's important to remember too that like the role. I know in this paper they talk about roles, but that's because they've kind of defined those in the paper. So roles are not in typical open source communities.
Yeah.
Roles aren't ascribed necessarily. I mean, sometimes they are. You can be a maintainer. I can hire you as a maintainer. But most of the time, the roles are going to be like informal, or they're going to be like kind of grow out of the interactions.
Yeah.
So a lot of times people just maintain stuff because that's what they do, and it's like they may do other things as well, and everyone might kind of share in the workload and do other things, but I guess if you go back to the reinforcement learning stuff that we were doing last week, I talked about the different types of issues, and I talked about Himanshu's project. Himanshu actually is also interested in this idea of different roles and having maintainers and regular contributors, and if you vary the number of maintainers versus the number of contributors, then that changes the dynamics of he's using a reinforcement learning algorithm, but it changes the whole nature of the community. So if you have more maintainers versus fewer maintainers, what happens? And that's like important because and it's not that you're ascribing that role, it's that more people take responsibility for maintaining the software because they maybe have a motivation to do so, that maybe it needs to be done, but also maybe they want just better software. I mean, you might have a monetary incentive. You might just say, I want better, I don't want this to be a messy project. Or you might have the reverse motivation that like people don't feel like it matters so much, and they end up running into a bunch of problems because no one wants to maintain anything. So that's those are all things that we could do here or to think about. And I don't know if you're familiar with Himanshu's work, but I can point, this is from several years ago, I can point you to the repository there.
Okay.
Yeah.
So regarding the roles part, I think this just represents the average. So in the project, we would obviously have to introduce some variance and standard deviation. So it actually mimics a real person. So I think that will need to be tested multiple times and we'll eventually get to a realistic value. And yeah, we would need to introduce some variance. Each contributor has a different graph, but it is closer to one of the 6 standard graphs. So I think that is one way we can mimic the real world. Okay, moving onwards. So the current LAMSOC capabilities and limitations. So the motivation update algorithm, I've talked about this briefly, but it is, I believe it is based on 3 signals: bit selection, PR merge success, and code quality score. These are what influence the current motivation in the project. So I think this is a bit simplistic approach. We can obviously make it better to have a bit more realistic, such as ideology, money incentive, etc. No conversation space emulation. I think this has been touched on before this presentation, that this can't mimic a real open source development environment. So we have to introduce one. GitHub discussion structure. Now the current project has this one panel, and most of the discussion occurs here. So that we are basically jumbling everything in one place. So I was thinking updating the front end a bit like the current GitHub we have. We have pull requests and we have discussions going on to in different pull requests like this. So that can be used instead of this. So that won't require much work. I think we would just need to tinker a bit with the front end and have the agents talk into the separate things. No personality configuration. Right now, the personality of an agent is written statically. So it is basically just one string which we can modify to change the agent's behavior. So we can just add a bit to the front end, which allows the user to use some pre-built or a custom personality that we can use. No role-based simulation of actions. Right now, they work on bidding for the contribution part. They are chosen based on motivation skill level. So I think we can add a bit of autonomy there. And for the conversation part, I think they just talk in a for loop. So that's not how a real conversation works. We have to give them individual autonomy, what they want to do based on their personality and their whatever role we give them. And I've talked about this before, the current model and my proposed newer model. And here are some of the references I found to similar projects. Now, I think this project has a very good starting point. Now, I couldn't find any research paper for emulating a Slack-like behavior, but I am able to find some GitHub projects. So I was thinking implementing something like this, wherever there's an event, then there's some randomness, and basically we use this architecture to emulate the current whatever message we want our agent to send, whatever conversation we want them to have. So for seed, this decides how the conversation will go. So to emulate different channels, we can have a different prompt. For example, I think in Slack we have a random channel. So there we talk about random things. I think someone made a Valentine's Day project. So that was pretty fun to go through. So we can have different channels based on this seed variable. We can have one string describing only serious talks, one string describing only informal talks, such as that. So through that, we can all use these references to have a better understanding for what we want to implement. So now proposed implementation I have for conversation space is this. The agent will I think I should go about one more thing here. That is turn order. Turn order. In one time step, we can only have limited actions, and this will be decided through an agent through this mathematical formula. I have found this through an paper. Now I'm working on this part, so I'll talk about this later. But whenever an agent's turn comes up, we will have basically two different LLM calls. One will decide what action it wants to take. Does it want to open an issue? Does it want to make a comment? Does it want to talk informally to the Slack channel? Then we have RAG part. Now this RAG part will retrieve the context and then we will execute our action. So the division of labor to two different AI calls will allow us to have a better result here. We don't dump all the decision burden onto one. This will allow us to have a better this will also have a better performance and emulation. Now about the RAG part, I'm thinking that the current messages and the long-term messages which are relevant will be emulated here. There will be a Slack message memory. This will have all of the informal messages, all of the channels, all the threads that was recently talked into. The GitHub comments, if the agent wants to go into the GitHub part, make a new issue, start a new PR. We can have a PR or issue if it want to review some previous issue or PR that has been published. And then the main part here is motivation events. We will decide how the motivation will be affected through some mathematical formula, or we can also ask some pre-trained sentiment analysis models, and this will make up the RAG retriever part. So after getting all this information, then the action will be executed, and then it will go onward to the next agent and the process will continue. And one final thing, now I'm thinking the presentation is getting a bit longer, so I like to end it right here. Now this is my favorite part of the project, GitHub profile scraper and personality configuration. So we have talked that GitHub users tend to have very vast different personalities. So to emulate that, why not we use the current GitHub profiles we have over the internet? So this will obviously be anonymized. We don't want it to get misused. So all the GitHub users will be hashed in the storage, and scraping will be rate limited, like one user data per minute or something like that, so that it won't be misused. So now here's my web scraper architecture I'm thinking of. We have the web scraper algorithm. It will get the data in a JSON format, and it will sanitize it through various means. It will hash it so it's not traceable, and we'll use an LLM to generate a personality text. This personality will help us emulate that person's behavior into our agent contributor. So these are the three main things that the web scraper will tend to analyze. First is the way of talking, how politely that person talks, and then we have action taken on an average. So this will help us identify maintainers and contributors. We can model it through that. And finally, the role part I talked about, we can predict it through commit, issue, and review and PR split. A person who is opening more issues is obviously focused on issues, so he is one of these engaged issue reporter or an occasional issue reporter. So through getting these data, I think I've seen this multiple times in a GitHub profile readme, that there is one graph similar to this one, which shows this hexagonal diagram, which shows how much this person is contributing as related to how much this person is opening issues. So through that we can map out one of the personality, and then we can obviously add some variance to emulate the real part. So that will do for my presentation. Now, any feedback on the next part I've talked about?
Yeah, so I think this part is. Did you go back to that equation you showed? I wanted to see something real quick.
Yeah.
Yeah, that one. So that's the turn order formula. So that's a softmax
Yes.
function that's kind of like with burst. It's additive with burstiness.
Yes.
Okay.
So
could you go through that a little bit?
Yeah. So I haven't actually worked on this. I ran out of time, but I like to give the gist of it. So we have the probability of an agent taking an action, and this probability will be calculated on, first of all, basis of the motivation. So the motivation is again a central part to this project. Then we'll talk about the action weights we will use. So that is will be based on the roles. Now we will have to add some variance again to make that more make it more realistic. Then there's burst. So we tend to see that the agent will do multiple functions at once. We see that in a conversation there's multiple times multiple messages to convey one overall message. Use so this burst will try to emulate how frequently there will be chunks to messages and actions. And the network part will use the page rank. Now this page rank wasn't clear to me, so it's in these docs. I'm working on this. I'll talk it about a bit later. I think I've ran out of time. I was reading through so many papers.
Yeah.
So
I think the page rank
this
algorithm is used as kind of like a way to go through like
yes
order, like rank your members of your network and then go through the order. I mean,
yes
they use it for very
yeah
large networks when they're doing search engine
yes
work, but you can use it on smaller networks, as far as I know. Like,
yeah. So we can divide one time step into multiple contributor actions. So we can use this to predict which agent is most likely to perform, and we can obviously add some randomness to it to add more realness. And what any thoughts about this part, web scraper to get the personality?
yeah. Yeah, so I've been talking about I've been trying to sell people on active inference, and this
Yeah,
is maybe active inference, or there's something here that is where it's relevant, right? I think that'd be
yeah,
good. But I like this kind of focus on thinking about motivations, and then like how to model that
yeah,
better, and
hmm,
and then the part about the web scraper, that's maybe a reach goal, because we have that once we get the data scraped, then we have
yeah,
to kind of figure out how it fits into the models. So it's not. I know it seems like we should be doing that first, but
yeah,
given the challenges I think I outlined before, we
yeah.
maybe don't want to open that can of worms.
Okay, so
But yeah,
should I omit this part and
well,
replace it with
you could put it as a reach goal. You could say this is something I'd like to do in the
okay,
future. I think it's worth
okay,
mentioning, or getting it on print. But yeah, I would focus on the motivations part, and then
okay,
yeah,
yeah, yeah. In my timeline, I think this is also placed a bit below.
yeah.
So here, yeah. So
Um,
the GitHub profile scraper is a bit below in the priority. And for my stretch goals, yeah, I'd like to also talk about this. So the Python packaging, this will make it more accessible, but this will be obviously a very hard task. So I'm putting it a bit below. And one more thing I wanted to see through is a core member missing in action study. What will happen if a core member goes suddenly inactive? So how can we see that without an active person, there's a gap of knowledge, there's a gap of skill? How can the community of less motivated and less experienced members will try to recover? I forgot about mentioning this part. So this study also seems relevant to the aim of project. And yeah, so I'll move the GitHub scraper a bit below.
yeah,
So it will be one of the stretch goals. However, I think it will be possible.
yeah. So a lot of this stuff I teach in my project management course is very relevant to like the core question there, which is like, how do you keep teams running and active? And
Yeah.
you lose a lot. Sometimes when you lose people, you lose institutional knowledge. So you can put it in
Yes.
documentation, you can
Hmm.
distribute it, or you can keep it in everyone's heads, and then you lose expertise. But you also can't avoid that sometimes, and that
Yeah.
is a thing. It's there's a motivation there. There's some alternate artifacts. Sometimes there are different ways you can organize a team to prevent that, or sometimes
Yeah.
exacerbate that. So yeah, it's this is all interesting, but I would just kind of really focus
Okay.
on the now the rag
Yeah.
part. So Riya also is thinking about rags. So
Yeah.
I am interested in this, but I don't know. I would like for you guys to maybe talk about this a little bit,
Okay.
and like what is it that what is it we can get out of this rag approach? Like, what is the
Yeah.
thing? Because I mean, maybe probably include Sarrah in that as well. Because like, what is the thing that you're trying to actually do here? I
Yeah.
mean, it'd be nice to have that kind of personalization or specific kind of training, but like, what can you actually do there with being useful? You know what I mean?
Yeah.
Yeah.
So I'd like to give the gist of it. The when we call large language models, they basically answer without memory. So through RAG, we are basically giving them previous memory that these things have occurred. This are your motivations, your personality, and then we are giving the AI to do the action. So RAG basically emulates the memory of an agent here.
Okay. Well, does it do that in a way that's the same as if I like had some
Yeah.
non-Markovian process where I just had like a list of specific things that was going on in the simulation versus like
Yeah.
knowledge about the world that it could draw from. I mean,
Yes.
they're different forms of memory. And it's interesting
Yeah.
though because the RAG allows you to have some context, right? Like,
Yeah.
but
Yeah. RAG.
yeah, yeah. So
Yeah. RAG gives us a bit of independence on how we want the LLM to process the data.
okay, yeah,
So okay.
yeah.
Okay.
But yeah, I heard most of the, I mean, I heard the presentation and it's good. Just the few things he talked about, but yeah, I think it's quite good. Did you share your timeline at all in the
Timeline
call?
isn't actually finalized, but yeah, I
Yeah.
can go through it.
Yeah, I mean, no, it's fine. I think, yeah, that's like the next thing because you've proposed a lot of things and
Yeah.
they're all good. But yeah, the schedule once you finalize, so make
Yeah.
sure it's,
Yeah.
achievable as well.
Yeah. Yeah.
Yeah, and maybe you can go into the 360 hours, so you can go longer than 12 weeks too if you wish. Like, that's always an option if you feel like that will be better for you. So you can do it as as you're confident about.
Okay.
Right.
Yeah. So I would have delved deeper to my um, timeline, but I just wanted to say that I'll have basically June and July for entirely free. I'm basically idle during that time, so I don't think time will be an issue. It will be the
Okay. Yeah, okay.
June.
There must be university holidays,
Yeah,
right?
yeah.
Vacations. Yeah, okay. Yeah, that's perfectly good.
Okay. So
Oh.
as soon as I finalize this, I'll send to you for the
Yeah,
review.
sure. Yeah, sure. You can send it to me in the doc format only. You can maybe make a group with Bradley and Morgan and Jesse
Okay.
and me. And just send the doc file for if anybody has any comments.
Okay. Thanks a lot for the presentation. I took a lot of time, I think.
I don't know. It's the presentation. Good presentation by all three presenters today.
Well, that's great. Thank you. Yeah, thank you, Akshat, and thank you, Sarah, for your comments. That was good.
Okay.
All right, Zavia, would you like to present?
Yes, sure.
Okay.
Okay, so I'm Kavya Zala, a second year undergraduate from VGTI. So this is a high level overview of what I'm trying to do. I'll first ingest the Slack corpus. So basically, we cannot uh, ingest live data like from Discord or Slack because it requires some admin permissions. And using third party tools has some legal implications, which I don't want to do. So I'll use some data sets for it. Then I'll extract behavioral personas from the extracted data set, so that we are giving an identity to the agent and it is also grounded to reality. Then we'll initialize the agents, and the agents can post messages, and we can have evolving states like motivation, experience, knowledge base. So talking about the data set, these are some of the data sets I went through. This is first one is the Chatterjee data set, which is basically a Slack data set, and its advantage is that it's already disentangled. So the threads are already disentangled in it. As you can see, the conversation IDs. So you do not have to manage different threads here, because normally what happens that although there are threads, but people do communicate in some other threads, and context does become entangled here. Second is the Discord dataset. So this is again Discord conversation datasets. It is not disentangled and will require external tools like Cody, which again introduces dependencies and environment issues. But its advantage is that it has interoptic distance map and 30 Syrian terms. Basically, what are the most common terms or topics that are being discussed here? Then third data set is the GitterCom one, which is not a Slack or Discord data set. It's from Gitter. So again, it's not disentangled, but it has advantages that what is the purpose of each conversation and what are the categories are already defined in it. And since disentanglement is a specific requirement that we will need for persona enrichment, I think we should move forward with the Chatterjee dataset. Okay, so moving to persona enrichment. Um, Actually, we have already initialized some personas in the code space while initializing the agents like their role description, the experience, the motivation. So what I'm trying to do is I'm trying to enrich them, basically add some extra personas that are required for chatting. So I'll extract archetypes like questioner, lurker, helper, or connector. Then sentiments, whether the conversation is positive, neutral, negative. How much has the user engaged, and how widely it engages across people. And this is the persona ideas derived from this paper, that is Generative Agents Simulacra, which is basically a Stanford paper. They are simulating your daily life through agents, and in that they have basically it's they have used the Sims, the game type of simulation, the Sims, and they are evolving state. So basically, each agent has some behavior, some memory, and as and when they are interacting, they are gaining some experiences and they are updating themselves. So how are we extracting? We'll first group the text according to the users, and then we'll extract this persona by passing it through LLMs. I know it sounds that we are using simply an LLM for this, but there are these papers that justify it, that large language models can actually infer the big five traits, although they have used GPT models and here we are using Llama. So I know that the accuracy will be a little less, but the thing is, the current architecture is already computationally expensive. So running the whole simulation takes up a lot of time. So I want to keep it as minimal or as efficient as possible. Another approach which I thought can be used is the paid one, which is a uh, zero shot extraction framework. So basically, the original paid extracts triplet. So basically, the subject, the object, and the conversation part, but we will have to modify it to extract the habits, goals, and characteristics. So paired is actually research based, and it has shown high precision, but in our case we would have to modify it, and also it requires external scripts and dependencies, which might not be great. So I thought of using just the LLM for extracting the archetypes and sentiments. Moving to this frequency and breadth, they can be directly computed using Python. Moving on to stratified sampling. So basically, I'm thinking we can have three types of agents: conversation space only agents, the overlapping agents which take part both in the code space as well as in the conversation space, and third is the code space only. Basically, this is derived from real OSS communities because normally there are some people who just contribute on GitHub. There are people who take part in conversations only, and there are people who take part in both. Uh, so basically, uh, this stratified sampling is needed because there is this 99-1 rule in oh, social activities, and this paper OSS 1991 confirms this, what the Priest paper is talking. But they have validated that although it's not 1991 exactly, but it's more or less similar, like 87, 5 and 2. So 90% of the users are basically the lurkers who just come and chat very limitedly, and 9% of the people who actually contribute a little, and 1% are the super users. So, but in our simulation, if we keep this kind of a ratio, our simulation will be pretty dead because most of the people would be lurkers, and they would not communicate much. So, in our simulation, I think we should uh, change the ratio a bit and keep five lurkers. Um, okay, so how would the overlapping agents map to the personas and to the original users of the uh, data set? So this is how we can map. So the existing code space traits can be matched with the compatible corpus archetypes like helper or connector, and these are some of the groundings from which I've inferred, though they have not directly mentioned it, but we can infer from these papers. Also, there are papers like Promise and Hicks, which show that OSS communities do require sentiments, uh, and the Hicks paper shows that there are different types of archetypes like helper, connector, questioner, lurker, helper who uh, helps continuously, like helps most of the time. Like whenever a question is raised, a person who helps, connector who basically is spread across multiple threads and provides recommendations. There's a questioner who asks questions, and of course there are lurkers who observe and send messages very less often. So I'm also thinking of evolving the agent states. Again, this is derived from the interactive simulacra paper, where people update the states using the memory and the type of interaction they have. So we can have updating um, motivations through experiences, like if a person is replying politely, a motivation increases, or by conversing more, we gain much more experience. So again, this cross coupling is what proves that we also need conversation space only agents, because they are not background noise. They actually help in the updating the code space one or the overlapping ones, because they update their motivation by conversing if they are being acknowledged, if they are being heard. Now, thinking about the memory management, I'm thinking of an architecture where we have short-term and long-term memory, and if it is not found in these memories, then only we move to RAG, because uh, RAG is actually computationally expensive. Making LLM calls, retrieving context, doing embeddings every time, so it's actually computationally expensive. So again, this architecture is derived from the life agents paper, and also cognitive science, like how we think progressively. First, we look into the short-term memory, then we gain some long-term memory if not found in the short-term memory, and then we search across websites or previous contexts. So Again, other memory architecture which I have seen is the Simulacra one, because it has short-term memory stream where all past events are stored. Uh, it summarizes the events into long-term memory, and they also have RAG. But the method they have used in the Simulacra one is actually expensive, as mentioned in the life agents. I've also take a screenshot from that paper and mentioned it here that the computation cost was $2,000 when it was done just run for 2 game days. So again, where should we apply RAG? This was the question. So I was thinking, should we also retrieve how was a similar situation handled from the data set I'm using, like the real Slack conversations. But if I do that, then it will be a replay and not emergence. Since we want to study the emerging behaviors, I think that's not the right way. So basically, what I'm doing is making initializing personas. That means I'm giving it some identity. But the paper like Composta shows that there are persona drifts. So basically, after a certain amount of conversation, the LLM forgets who he is. So we'll need to re-inject some examples so that he gains knowledge of his archetype, sentiment. So we will do few short prompting for this, and this was the paper that I used to get the architecture. And also, we just can't keep simple personas. Yes, I mentioned it. So yeah, so RAG should only be used to retrieve the conversation info and not from the data set. So uh, RAG, I'm just saying that RAG should be used to get info about the current conversation that is happening in the simulation and not from the data set. Okay, so moving on to the RAG requirements, I think the vector DB should be chroma DB, since the simulation is actually incrementing. So the data is actually generating in every timestamp. And so if we apply just phase, it actually does a re-embedding of the whole simulation again and again. So it's again very slow. Next, and ChromaDBs doesn't do this. So basically, you can have incremental embeddings without redoing the whole embeddings that has already happened. And this is the benchmark for selecting the embedding model. Basically, we can't use the Olama embeddings because it takes a lot of time. As you can see, the corpus speed, and basically corpus speed is the time that it takes for the whole document to be converted into the embedding. And STS score is the semantic similarity score, so how much it is correct to the real semantics. So I'm thinking we can use this model as it is comparatively faster.
Oh, that's great. Yeah, I think you got a lot there. Thank you for presenting. Yeah. So, Sarah, you wanted to say something?
Yeah. Well, one basic question, but so you had like the heading for your presentation was conversation space. So, is this your presentation? Is this what your proposal will be, or are you currently just telling us your plan for conversation space and you plan to add more later?
Yes, so I plan to add more later. So as I mentioned, I haven't done a research about the metric part and the new algorithm part. So I just mentioned that the heading is conversation space because that is what I was discussing in today's session. Okay. And then like a few questions. So firstly, when you presented the data set, again, I was going to tell you this, which you clarified yourself, that we won't be doing RAG on the data set. So the data set there's two separate things you're targeting here. One is the persona creation on the basis of the data set. So it would be similar to how Akshat said that maybe you should, take real GitHub personalities. And so instead of that, you're proposing we do that from the Slack dataset. And then the separate part is actual conversation space between the current agents. Yes. So there will be 3 types of agents. One is just the people who chat, just the people who contribute, and both. So the main part is how will we connect the code space agents with the actual Slack database, Slack users. So
Right.
for doing that, I have showed the mapping using archetypes, which I've also mentioned some papers around.
Right, but I understand the archetypes part, but then how would you actually do it? That was my exact question. Like, so you get the data set and you work on creating the personas, and the personas are now created. So every time you have an agent, they can have some random persona, I'm assuming, out of the ones that are created.
No. Actually, the code space already generates a role description, right?
Right.
It also creates experience, right? And motivation. So
Hmm.
I'm going to use that experience and motivation to link it to the archetype. So basically, there's an overlap of archetypes also,
Right.
which can help to map both of them. So I'm using the experience and motivation from the code space agents to map them to the real Slack users and giving them an identity. So also I'm giving the extra archetype, extra persona so that they can chat.
Okay, so you're saying that you would first ingest all the real world Slack data, then
Yes.
try to identify certain archetypes within that, then try to identify similar archetypes within our existing code space agents, then
Yes.
map them the way they best match, and then you would attach a persona to it.
Yes, basically I'm mapping them on the basis of the persona. So the final agent that we will create will have the personas required for conversing as well as for the code space. That is for the overlapping part. And for code space agents, we do not need these personas as they already have. So we'll keep them as it is, no changes required. And for conversation space, only agents, whatever the archetypes we have extracted, they are enough for conversing. So
But
we'll
the
keep that.
point of the data set is to understand what different types of personas exist. And
Yes.
but then how are you connecting that to actual real world Slack data? I'm still a bit lost.
So the dataset actually contains the real Slack conversation. So I'm extracting sentiments from those conversations, like how this user is.
Right, but that's not. So that data set is old, right? It's made. So what about a new when you say real world Slack data, you're saying for every simulation we'll be having that data set only. It won't change from simulation to simulation.
Basically, the dataset actually has three OSS communities. One is the Python dev, another is Clojure, and third one is Elm. So basically, we will have to use these datasets only because if we try to ingest real world data, there are third party tools, but there are some legal implications that might have.
Licensing issues. Yeah, okay. Yeah, okay. Just wanted to confirm. So okay, so then maybe it'll be one of these three. And then why you trying to make personas and not so it's different each simulation? Is that why? Instead of just taking the users as they are from the data set?
Basically, I'm extracting personas to. Basically, this is what research papers have done. Like this, the generator Simulacra one, the Camel one, where Camel one also is actually a simulation of the how people respond on social media, how they react to posts. So there also they have done the persona extraction part, or actually they have most of them have actually created the persona themselves, like we have done in the code space. Like we gave the agent an identity. So basically, I'm trying to give the agent an identity of who he is, so we can have individuals or individual identities of each agent.
Okay. Yeah. Okay.
So yeah, I think you're burying the lead with your project title then. In a way, yeah.
Yeah, sorry for the title because this is actually
That's fine.
Yeah, no, it's okay.
Yeah, I think that's
any
good.
other doubt?
Yeah, I think you've hit a lot of points here, and then you're also talking about RAG. So I would get together. I mean, I know that you're all competing for GSOC, but I would get together and talk about how to do RAGs and how this would be best done. Because I think it's like, we don't want to have like 4 different rags floating around and people saying this is the way it should be done. Because this is a nice feature to have. You can train a model, get some context, and then I think Xavier mentioned that you have this, like we talked about this before. You have this difference between the previous experience within the simulation, and then there's this context that you can draw from, and you can use that to inform the model. So if like the rag that we built for the cyberneticists that I keep talking about, if we write a paper if we have a reading group and we're thinking about what, say, Norbert Wiener had to say about something, and we've read one book, we maybe read a couple other papers, but if we train a rag on his work, we can then go back and say, what would Norbert Wiener say about this concept, and then it would give us some output, and we could look at that and say, okay, well, this is what we've kind of come up with in our reading group, and it might add something. It gives context, and we can use that as another piece of information to sort of, so it's like history, but it's also like history from a wider lens than like that one experience of the simulation or the runs that you give it that it has experience with. So I think that's interesting, but we have to kind of figure out how to implement that correctly and how that would best serve the model.
Actually, the current architecture is already very heavy, so
Yeah, I know.
that's a bit of a problem because running the whole simulation takes a lot of time, and the
Yeah.
laptop fan just starts spinning and producing noise.
Yeah, it is a problem, and this I think is something important to remember, is that like we have to make
Because
sure that it's memory efficient, right? We don't want to add everything. I don't want to add the kitchen sink and then have the whole thing not be able to run because we have too much in there.
yes, so that is why I was looking at the architecture from the research papers, but actually those are very heavy, so we cannot actually implement them in our simulation. So that is what we will have to make some tweaks and remove some heavy parts from it.
Yeah. Well, that's again like that's strategizing, right? Okay. All right, so I think everyone did a good job here this week. I wanted to give people a chance to go through their projects, so I think everyone did well. And hopefully we can get our project deadline is next Tuesday, 31st. I say this because it's very important that you meet the deadline exactly. Figure out what time they want. Like I don't think it's anywhere on Earth at the end of the day. I think it's like a specific time. UTC. So make sure you have that right. And then again, your project proposal is the outline of what you want to do. Make that very clear. But then also you have the schedule, go through week by week and say this is what I'm going to do. But also if we have reach goals, if we have ways that we can get around bottlenecks, point those out. Because sometimes we hit things that we can't solve right away. We need to we don't want to waste time sitting on something for a week when we could be doing something else and then come back to that later. So prioritization is also important. Okay. So I don't know, Morgan, I know you've been waiting patiently. I hope you've enjoyed the presentations. And so why don't you give an update on what you've been up to?
Yeah, I certainly wasn't waiting patient or like I just turned my camera on. That's all.
Yeah.
Yeah. Thanks everyone for your presentations. I am trying to understand this area myself. It's not my thing, but I find these simulations really interesting. And as I presented last week, I'm trying to use some large scale LLM simulations for a variety of purposes, and I'm just kind of using Sustain Hub and the open source sustainability project is some drawing inspiration from it. Yeah. So just not sure what to cover this week in particular. We did we talked about focused ultrasound at the tower. We had the chief scientist of Attune Neuro speaking. So this is a focused ultrasound company that uses you've got some small thin parts of your skull right here that focused ultrasounds can use to they call them temporal windows to allow for neuromodulation of brain areas. His particular group is doing some really interesting work with UCSF, not only on depression and chronic pain, which of course are typical targets because of the large size of need. But my research area is in psychosis and in particular schizophrenia, and he's together again with someone at UCSF doing really interesting work in terms of symptom modulation in schizophrenia with focused ultrasound, which is fascinating. This week was a diffusion in Python workshop. So this is a week of online discussion around DPI. I heard people saying DPI. Yeah. Do you have thoughts on this, Bradley, about how to say, NIPY?
DIP or no? I mean, DPI sounds like you're trying to unpython it, which maybe is better. I don't know.
Well, it's so it's confusing, right? I mean, yeah, this is the problem if you don't work with people who are, if you're always just using chat to talk to people in other countries, you don't hear them saying it out loud. I feel like the Python people want to say "ni" because of Monty Python and the Holy Grail.
Oh yeah.
Is that why they say it like
Why
that?
the pie or what do you mean?
Well, because they're saying DPI, and I'm like, it's DI. Like.
Oh yeah. Yeah, I don't know. DIPI.
Yeah, well, so it's not like NiPi is the neuroimaging in Python is NiPi.
Yeah.
So NiPi.org. But I think the NiPi people actually, like, if I met them in real life, I think they would say NiPi.
Yeah.
But the interesting thing about it, I mean, it was they used the workshop as an opportunity to kind of talk about their development release. So you get to see kind of new features and things like that. The important thing for what I hope would be a weekly segment is the coverage of AI in medical imaging. Okay. And this is a particularly I think an interesting topic also, because if you remember, although this seems like can this already be like 10 plus years ago? Jeff Hinton said AI is going to replace all of radiologists. We won't need radiologists anymore because of AI. What, am I right, Bradley? I mean, was that like...
Yeah, that was the idea, that the radiologists would be replaced.
But wasn't that like 2015?
Yeah, it was a long time ago.
Like a crazy long time ago. So if you check your hospitals, your neuroradiologists are fine.
Yes, they're all there still. Well, maybe not all there, but
they're still there. It's still still a functional discipline, still being taught in medical schools. But it's interesting, right? Because at the same time, we are seeing a lot of, there's a lot of progress in models. There's a lot of progress in segmentation. Segment anything is a really useful tool, and I follow some groups that work with it. So people were covering, people were talking about how it's used in both, acquisition from the MRI. So can you design a sequence that kind of like runs faster, so that you don't have to have the person in the scanner for as long, or again, in some way make the scan itself more amenable to kind of deep learning approach. And but I gotta say, I think it was really somewhat lacking as a session, and I think we should talk about why. This will be part of a like an opinion piece that they're going to put out after. But I did I didn't speak until the end, where it talked about agentic coding, or like AI assisted coding. And so I did submit my diffusion microstructural imaging in Python project, which is like my refactor of an old project that was, NumPy based, and that I've refactored with JAX, and that I've been using not only coding agents to parallelize the code, but also to extend it in new ways that, in particular, like I presented last week, use this JAX ecosystem, and specifically something I call the Kidger stack, which is just a set of libraries that are designed for neural differential equations in machine learning. So pins and related approaches. So I would just say, for those interested in those kinds of approaches, the talk that I dropped in the Data Sci channel, it doesn't come with a thumbnail, but is the American Mathematical Society talk. And unfortunately, to make it even worse, he's the second speaker. So you first have to go through a conversation about, an interesting one about biomimetic robots, swimming robots. But George Takanidis, I'm not even coming close to getting his name right.
Yeah.
But he's the head of Crunch Lab at Brown, has been a pioneer in pins, has, he or his students have developed most of the PyTorch tools that people use for these approaches. And he has the first time where I've seen somebody like him actually talking about agentic AI for computational science, right? And I think that's really interesting that he's, in addition to talking about what he was calling second generation pins and second order optimization for them, and some dramatic results in terms of improvement, which I have got to follow up on. But he's also taking a very, if you remember, Bradley, the Gas Town simulation.
Oh yeah.
Yeah. So this is like you know, again, it kind of reminds me of Sustain Hub in terms of, or you know, the open source sustainability. Like you've got a community of developers that you're using. I mean, a community of coding agents, and that's what Gastown is all about. And so yeah, he lays out this kind of Gastown approach to formulating a computational model. So he's not trying to do an AI scientist, but he does have like certain agents that are the actual coders, certain agents that are kind of like the designers. I mean, it's funny because it kind of looks like an academic lab.
Yeah.
Where he's got like the PI and maybe some other senior people are coming up with ideas, and then there's like postdocs.
Yeah.
Sorry, I'm not sure what that says about his particular vision.
Yeah. Well.
But I'm trying not to read too much into it. But I think I'm interested in that particular approach. Well, how to make things more autonomous.
Yeah.
And I mean, and you know, again, sorry, I don't know if you can hear this really loud siren. Sorry, I'm downtown San Francisco.
Yeah.
We get the full, sounds of the city. But you know, again, like what I'm trying to do is, as I presented at the conference or the workshop, you know, I'm trying to see this in action and see, you know, what it's capable of doing. You know, if so, and you know, making the other video that I posted was Andre Karpathy talking about his own, you know, auto research project, which is you know, again, it's a super simple idea that is something that, you know, you it would be your first approach to doing the kind of thing that Crunch Lab is doing in terms of giving an agent a kind of task to iterate on and not need the human to be in the loop. So Karpathy talks a lot about trying to remove the human. It's not that the human's unimportant, but that, you know, the human's the bottleneck in a lot of the work if you know, tokens are free and, you know, to some degree compute is free. I know those are not true, but
right.
Anyway, but I think it's really interesting. You know, I think it's really interesting to hear him talking about it. I've got some. I mean, I've trying to make everything runnable here just on a DGX Spark, but it allows us to go to use cloud compute if things are if it seems worth it, but really trying to get as much out from the GPU as possible. And like Bradley said, you know, I'm trying to use things like the organoid benchmark as something to iterate on. So Karpathy talks a lot about in his auto research is that, you know, this is really good if you've got good metrics, right? So if the agent can be trying new things, as long as there's good, you know, there's real tests to see if this is an improvement in the right direction. So I'm in addition to the organoid benchmark, I'm using some diffusion benchmarks to microstructural MRI benchmarks, and most recently is the real-time fMRI benchmark that from the Mind's Eye project. Yeah. So if anybody's interested, please do check out my GitHub. I've been dropping. So the new repos that again Claude has generated. All of the training materials in terms of the kind of educational materials for learning about these projects is in the spinning up in I say ALF. It's supposed to be active inference framework, but I think ALF sounds better. And one of the new repos you'll see there is Evo Embodied, which is my attempt to rewrite Josh Baumgart's evolutionary robotics course with a new software stack. Right. That again is JAX based, is Mujoko, a rewrite of Mujoko that's JAX, and but still keeps a lot of Baumgart's kind of having the body itself be part of the evolution, so it's not just evolutionary computation. It's an embodiment that is also being iterated and selected. Yeah. I think that's it. I've got one coming to talk about. Something trying to go. I don't know if this repo is public or private currently, but I'm trying to do, trying to think about larger simulations that kind of drop the LLM. Yeah. And in terms of very large simulations, and potentially ones that you'd actually be interested in using quantum computing. But these are really just large icing models and spin glass models. Okay. But as you see, I'm trying to connect the. It's interesting that the math behind these is actually similar for large-scale social interaction models. Yeah. So if you're interested in learning about that, again, check materials, or I'll make the material public. But it is, you can see this in, disordered magnet systems. Yeah. And, it's an interesting intersection of actually like material science modeling and large-scale multi-agent simulations. Yeah. Yeah. Obviously, you lose a lot of, you're going to lose a lot of the theory of mind kind of. Oh, yeah. Well, this is kind of like mid-90s Santa Fe Institute, where they were like putting... This is yeah, but actually, this is like current... oh, yeah. This is current work. So, Aram Narabi from Carnegie Mellon, who just spoke at Santa Fe Institute. He also spoke at Foresight and was talking about trying to do these kinds of simulations. These are kind of simulations that you can also prove analytic. You can prove some things about analytically. Yeah. Right. Which is the kind of stuff that he's done in terms of finding lower bounds to certain properties of the system. But again, just would be, it's an interesting connection to these kind of multi-agent system models.
Yeah. I mean, now that we have much better compute than they had when they started doing spin glass models. I mean, they're largely theoretical when they introduced them. Like we talked about this in
Yeah.
Deworm, where like it was a product of kind of thinking about magnetic spins and then putting that into a network, and then
Yeah.
or an agent based kind of paradigm, and then people started using it for different types of biological and social systems and making that analogy, but then getting the compute right and getting insights out of it is a different issue. So that's why people are working on it, I guess, still. And yeah, I think it's great.
Yeah, it's so please check out the educational material, because it's like I'm really trying to find the right kind of scaffolding for this in terms of how to approach it. But this will be something where again, if quantum compute becomes available, I'm going to try and submit a grant for just getting some compute access,
Right.
For, limited compute access via NASA
Okay.
for some quantum simulations.
Oh wow.
And yeah, but I think it's still something, yeah, that you can connect to social simulations.
Yeah. Yeah, Luke, sounds good. Sounds good. Glad to hear you're doing all the things, apparently. Yeah. All right. Well, thanks for attending. Thanks to everyone who presented today, and let's keep working on our applications. And we have a lot of things in the, and I didn't even talk about it, but we have a lot of things in the GitHub repository that are sort of, I'm not really sure of what needs to be pushed and where we're pushing them. I think we're pushing everything to dev now, but I think that's good for like, the
Yes, we have
application
changed the
period of
main branch.
application period of GSOC. But there's still some things that are open, so I want to know. I'd like to know more about like what the status is, what can be pushed, and so forth. But I'm glad everyone's been at least engaging and getting things out there and really being interested in that repository. So thank you. All right. See you next week.